Hey guys, so here's the notes to section 2.7. Once again, we're going to be using synthetic division to find our zeros, but now we're going to also be talking about repeated zeros. So remember, when we first talked about the fundamental theorem of algebra, when we were basically doing solving by factoring, we talked about if the degree, whatever the degree is, that's how many solutions you have. Now we're going to include our repeated zeros or repeated solutions. So remember we talked about that these are solutions that occur more than once. And later on, we're going to be talking about what are the implications to the graphs when we do have repeated solutions / zeros. So remember, solution zeros, they also represent x-intercepts. That's where it crosses the x-axis. So now we're going to go ahead and find our solutions. So we're going to find all the zeros of f of x equals x to the 5th minus 4x to the 4th plus 4x cubed plus 2x squared minus 13x minus 14. That's a mouthful there. Given that 2 is a 0 and -1 is a repeated 0. Okay, so notice that we're going to find all zeros. Now, meaning this could include imaginary numbers. So when it says all, that means complex. So both real and imaginary solutions if possible. Now, first, using that fundamental theorem of algebra, let's talk about, well, how many solutions are we going to have? Well, what is the degree of this polynomial? Our degree is 5. So that means we should have 5 solutions at the end here. Now, they have given us these zeros, just like we did when we did 2.6. So we're going to use synthetic division to help us do that. So let's start with the given 0 of 2. So I do 2, I do my box, and I do my synthetic division. If you would like to kind of just practice synthetic division, go ahead and pause this video to do this first step. 1, -4, 4, 10, -13, and -14. So notice here that I don't have any missing terms, so I don't need to use 0 as a placeholder. So I multiply, -2, -4, so I get 0. That'll be 0, 10, 2, that'll be 20. I get 7 when I add here. 7 times 2 gives me 14, and we do get 0. So don't forget, when they do give you a 0, you should get 0 as a remainder. Now, usually we would stop there and then factor more. But notice they gave us more than one 0. So what we're going to do is continue on and use synthetic division again to go down. Because remember, when we use synthetic division, we just only go down 1 degree. So our coefficients here would be the degree of 4. So the other 0 they have given to us is a -1. So we are also going to use -1 and use synthetic division again. Okay, so using this, I have 1. I multiply, I get -1, so I get -3. I get +3. And I get -3, so I get 7. I get -7, and I do get 0 as my remainder, so I did this correctly. Okay. Now we look, we don't really see any more numbers in our wording, but notice here, it says -1 is a repeated 0, okay? Now notice they only say it's a repeated 0. It doesn't tell us how many times it repeats. Well, how do we know when to stop using synthetic division? Well, notice here that when we did our first, this would have given us 2x to the 4th. When we did it the second time, once again going down 1 degree, it would give us x to the 3rd. What we want to do is use synthetic division until we get to x squared, so a degree of 2. Because once we get to x squared, we have numerous ways of factoring. So we can either, of course, factor, or we could use quadratic formula to solve that quadratic. So when it says -1 is a repeated 0, well, we've done it once. Let's go ahead and we're going to try it again so we can get our polynomial down to a degree of 2. So I'm going to use -1 once again because it's repeated. So I bring 1 down, I get -1, so I get -4 here. Then I get a +4, I get 7, and then -7. And of course I do this correctly because notice I do get 0 as my remainder. So anytime they do give you zeros, remember you should always get 0 as a remainder. So now this is going to be an x squared. So So now I can go ahead and write this out and then either use factoring or quadratic formula to solve the quadratic equation. So I have x squared minus 4x plus 7 equals 0. So I do 2 sets of parentheses. I'm going to see if this is factorable. Okay, I have 1 and 7. Now if I think about 1 and 7, can that really get me anywhere to negative 4? No. So really we can't use factoring here. Instead, what we're going to use is a quadratic formula to solve for our values. Now remember, we can get any number. So we could get imaginary, we could get rationals or irrationals, just depending. Okay, so if x equals, our b is going to be opposite, so it's going to be positive 4. And I'll write it here so we remember. So remember, quadratic formula, opposite of b, plus or minus b squared minus 4ac over 2a. Guys didn't think you would see this again, but yep, we do. Okay, so I get 4 plus minus negative 4 squared minus 4 times our a, which is 1, times our c, which is 7, all over 2 times 1. Now don't forget, we want to plug what is underneath the square root into our calculator. Okay, so we have negative 4 squared, which is of course 16, but we will still plug that in there. Squared minus 4, then times 1. And notice I'm not putting the square root sign, I'm just plugging in what is underneath. I get negative 12. Okay, so I have 4 plus or minus square root of negative 12 all over 2. Okay, let's go ahead. We're going to simplify that square root of negative 12. So remember, when we have negative, that represents square root of negative 1. Then for 4, the perfect square that goes into it is going to be 4. Okay? So when I simplify this, I have 4 plus or minus. Square root of 4 is 2. I will have I because square root of negative 1. And then square root of 3 all over 2. Now, because I have imaginary, I do want to simplify this. So I am going to take my 4 divided by 2. So that'll just give me 2. And then I'm going to have 2i divided by 2. So don't forget the plus minus. So 2 divided by 2 just gives us 1. So I'm left with I and then square root of 3. Right? So all my solutions, I'm going to write them out now. All the solutions I have. Now don't forget the ones that we did in our synthetic division. So we have 2. We have negative 1 repeated twice, and then we have our 2 plus or minus I squared of 3. And let's count and we see and get 5 solutions. So we get x equals 2, x equals negative 1, x equals negative 1, and x equals 2 plus or minus I squared of 3. Okay, so x equals 2, that's one solution. And x equals negative 1, that's the second. X equals negative 1, that's the third. Don't forget that plus minus represents there's 2 solutions. We have 2 plus I squared root of 3 and 2 minus I squared root of 3. So that represents 2 solutions. So we get 5 total. So we did this correctly because we do get 5 solutions. And last thing, don't forget, because we do have an imaginary or a complex solution, remember, write it in standard form. So that is your real part plus or minus the imaginary part. Okay, make sure you watch the next part of the video. Once again, we're just going to do another problem similar to this.